Good morning, all you Sioux High Earth Science students. Yes, rise and shine. It's a frigid minus 14 degrees. Welcome to our next series of podcasts on oceans and ocean currents. Time to get your notes out and something to write with. And let's see what we can learn. See what I did there? S-E-A? I just did it again. You know, sea like the ocean. Okay, let's get to work. Just a few ocean basics to get in your notes. First, as you can clearly see, 71% of the Earth's surface is covered by water and oceans. And those contain 97% of the Earth's water. Next, write that all the oceans and seas are actually one continuous body of water, and that oceanographers are the scientists who study the ocean and its processes. Also get in your notes that there are four main oceans on the Earth: the Atlantic, Pacific, Indian, and Arctic, and that the Pacific Ocean is the largest ocean. In fact, the area and volume of the Pacific Ocean are greater than the Atlantic and Indian combined. Now, what's the difference between an ocean and a sea? Write in your notes that a sea is one of the largest bodies of salt water found on the Earth's surface. However, seas have less salt water than an ocean, The most famous seas on the Earth are the Mediterranean, Caribbean, Black, and Arctic seas. So make sure you have those as examples in your notes. So, where did the Earth's surface water actually come from? Write in your notes that when Earth was still a young planet, many active volcanoes existed, and that as they erupted, lava, ash, and gases were released, and one of these gases was water vapor. Over millions of years, the water vapor cooled enough to condense and form clouds. Then torrential rains began to fall from the clouds, and eventually, much of the land was covered by the water that formed. So make sure you have that explanation in your notes. Okay, now what's in the oceans and in ocean water? Write in your notes that ocean water is a mixture of gases and solids dissolved in pure water, and that oceanographers believe oceans contain all the natural elements on the Earth. In fact, 85 of the 90 naturally occurring elements have been found in the ocean. Also write that the actual salt in salt water, called the salinity of the salt water, is the dissolved minerals from the rocks the water sits on, and contributes to its temperature, density, and color as well. Ah, yes, please get this diagram in your notes right now. You're going to need it. So there are four major oceanic zones where plants and animals live in the ocean, and we want you to get those in your notes. The four major zones are the intertidal zone, which you see right up here, intertidal zone, the neritic zone right here, the open ocean or oceanic zone, and then the benthic zone would be the fourth one. Here's our benthic. They call it the benthic realm, but we're going to call it the benthic zone. Now, these zones contain the largest ecosystem on the Earth. Let's get a brief description of each in your notes. First, let's talk about the intertidal zone. The intertidal zone is the area of the seafloor between high and low tide and bridges the gap between land and water. Also write that tide pools, estuaries, mangrove swamps, and rocky coastal areas are all a part of the intertidal zone. Okay, next is the neritic zone right here. The neritic zone is the water above the continental shelf where underwater forests of coral, kelp, and grassy meadows of seagrass are home to lots of fish, turtles, cows, etc. So that's the neritic zone. So again, just now next to the intertidal zone. Now, the next zone is the open ocean or oceanic zone, which lies beyond the continental slope and contains 65% of the water in the oceans. Now, this zone is divided further into 3 subzones we need you to get in your notes. Now, the first is the photic zone, also referred to as the sunlit zone. And this is where photosynthesis takes place. Most animals living in the open ocean live in the sunlit zone. Now, just below the sunlit zone is the aphotic. You see the aphotic. Some refer to this as the twilight zone. Now, this is where light penetrates up to about 3,000 feet. So make sure you get that in your notes. And there's a bunch of fish, squids, etc. that live in this area. And then the last one is the abyssal zone, otherwise known as the midnight zone. And this extends from a depth of 3,000 feet to the sea floor. So all the way down to the sea floor is the abyssal zone. And it has a bunch of animals in it too that we're not going to really concern ourselves with. But those are the zones of the open ocean or oceanic zone. Now the last of the 4 zones is the benthic zone or the benthic realm. Now this zone includes the entire seafloor and about 200,000 species of plants and animals. Now they live on the continental shelf and the continental slope itself. So hydrothermal vents discovered in 1977 are also teeming with life. We call those thermophiles. And these plants and animals do not need sunlight to live. So, why in the world would we want to pay any amount of time learning about the oceans? Well, we've already mentioned that they cover over 70% of the surface, and because of that, they play an extremely important role in our lives, in the lives of all living organisms on the planets. Let's get some key functions of the oceans in your notes. First, write that oceans transport heat from the equator to the poles. Secondly, write that the oceans transport nutrients and organisms all over the earth as well. Then thirdly, recall that the oceans have a tremendous influence on our weather and climate. And then finally, from a social studies standpoint, write that the oceans also influence commerce due to commercial shipping, much like our own Great Lakes do. So make sure you have those 4 functions in your notes. Okay, now let's talk about the ocean currents. First, write in your notes that an ocean current is a continuous, directed movement of seawater generated by forces acting upon this water. Also write that examples of forces that cause currents are wind, the Coriolis effect, cabling, temperature, and salinity differences. Also write that depth contours, shoreline configurations, and interactions with other currents influence a current's direction and strength. Also get in your notes that currents are broken down into different classes. Surface currents, which occur in the upper 400 meters of the ocean and represent about 10% of the current. And then there are also deep water currents, which represent the thermal and salinity currents, which make up the majority of currents at 90%. So make sure you get those in your notes. Another type of current is the wind-driven surface current. Write in your notes that wind-driven surface currents are currents that are created by the force of wind exerting stress on the sea surface, and that this stress causes the surface water to move, which is then transmitted to the underlying water, or the water underneath it. Also write that the depth is dependent mainly on the strength and persistence of the wind. Get in your notes that most ocean currents are the result of winds that tend to blow in a given direction over long periods of time. Now, surface currents are affected by three different forces we want you to get in your notes. Solar heating, which is responsible for temperature and density of the water, winds, and the Coriolis effect. So get those three forces in your notes that affect currents. Okay, next let's talk about the importance of the interaction between surface and deep sea currents, and then get some important results of those interactions in your notes. First, write that these current interactions play a significant role in transporting heat energy from equatorial waters. Obviously, equatorial waters are waters near the equator toward the poles. So if you can imagine the equator right here splitting the Earth in two, we're talking about movement this way and movement that way. So those surface and deep sea current interactions move water from the warm pole or warm equator toward both poles. Secondly, write that these interactions are also involved with gas exchanges, specifically oxygen and carbon dioxide. We know that photosynthetic organisms give off breathable oxygen, and then organisms like ourselves take in that oxygen and give off the carbon dioxide that those plants actually need. Next, get in your notes that these interactions provide the nutrient exchanges important within surface waters, and that includes outflow from continents and also deeper waters. We call that upwelling and downwelling, and we'll get to those here in a bit. Also write that unfortunately these interactions also allow for the dispersal of pollutants and function in distributing major oil spills as well. And then lastly, write that these interactions also have a major impact on fisheries and other resources. Okay, in case you haven't noticed, that was a ton of notes to write. So we'll wrap that up as part one in our ocean discussion. So take a picture of those notes, send that picture along to Moodle, grab the study guide, answer those questions, and I will see you back here in part two of our discussion of oceans. Bye.